Large language models, or LLMs, represent a groundbreaking advancement in artificial intelligence, capable of understanding and generating human-like text through, complex computational processes. At their core, LLMs are deep learning models trained on vast amounts of textual data, enabling them to predict and produce coherent language based on patterns they've learned. The foundation of modern LLMs lies in the transformer architecture. Introduced in the seminal 2017 paper Attention is All You Need by Vaswani and others, which really revolutionized natural language processing by addressing previous limitations in handling long-range dependencies in text. Training large language models, or LLMs, presents numerous technical challenges beyond just computational requirements. Data quality and diversity significantly impact model performance, requiring careful pre-processing to remove biases, toxic language, and low-quality content while maintaining broad coverage of linguistic styles and domains. Tokenization, the process of splitting text into manageable units, requires balancing vocabulary size with the ability to represent rare words and morphologically rich languages effectively. Modern approaches like byte-pair encoding, BPE, or WordPiece provide subword solutions that handle out-of-vocabulary terms. The massive scale of these models also introduces deployment challenges, leading to techniques like model parallelism, distributing layers across multiple devices, quantization, reducing numerical precision to save memory, and distillation, training smaller models to mimic larger ones. Ethical considerations loom large as well, with concerns about biases inherited from training data, potential misuse for generating misinformation, and environmental impacts of the enormous energy consumption required for training and inference. Recent advancements continue pushing the boundaries of what LLMs can achieve. Techniques like reinforcement learning from human feedback, or RLHF, fine-tune models to better align with human preferences, improving coherence and safety in outputs. Multimodal models extend the architecture to process not just text, but also images, audio, and other data types, enabling more comprehensive AI systems. Architectural innovations like sparse attention patterns, mixture of experts designs, and retrieval-augmented generation improve efficiency and capabilities while managing computational costs. The field also explores ways to make models more interpretable and controllable, with research into attention visualization, prompt engineering, and steering vectors that allow users to guide model behavior more precisely. As LLMs become increasingly integrated into applications ranging from search engines to creative writing assistants to programming tools, understanding their inner workings becomes crucial for both developers leveraging their capabilities and society grappling with their implications. While current models still struggle with factual consistency, reasoning depth, and contextual understanding in some scenarios, ongoing research in areas like neurosymbolic integration and memory augmentation promises to address these limitations, pointing toward even more sophisticated language understanding systems in the future. The rapid evolution of LLMs demonstrates both the remarkable potential of artificial intelligence to process and generate human language and the complex challenges that accompany such powerful technology, requiring continued innovation in both technical and ethical dimensions to harness their benefits responsibly.